Howdy PreCal, it is Miss Kosh. This is the second and final, yes, I'm going to make it the final video on 3A. Well, unless I get inspired later, but the final video for right now of graphing and inversing, which may not be a word, but we're taking the inverse of exponential functions. All right, so I already did all of this in the previous video. I'm trying not to make you dizzy as I go quickly. Go find that video and watch it. I'm going to assume that you did, and then we're going to look at switching our x and y. So we're now going to take we're now getting to the inversing, which is taking the inverse of this exponential function. So on here, we have this lovely exponential function. I'm going to graph this one. Oh, my pencil turned off. I'm going to graph this one in blue. And so notice that I've got an asymptote at y equals 2. And I have the point, and it was already nicely provided for me. I have the point 1, 3. I have the point 2, 4. I have the point 3, what is this, 1, 2, 3, 4, okay, that was 4, 5, 6. I have the point 4, 10, I think 10 should be the top. 6, 7, 8, 9, 10, yes it was. And so it's going to look something, this graph is going to look something like this. On this one, oh, which is the pivot point? Do you know? Take a second, try and figure it out. Remember, our pivot point is initially in the parent functions. It's at 0, 1. And then what did we do? We went right 1 and up 2. So right 1 gives us a 1, up 2 gives us a 3. And so this 1, 3 was the pivot point, in case we're curious. So now when I take the inverse, I'm going to switch my x and y's, and I'm going to switch color. And this becomes a 3, 4, 6, 10 is now my x value, and a 1, 2, 3, 4 is now my y value. So let's plot the point 3, 1, 2, 3, 1, and the point 4, 4, 1, 2, and the point 6, 4, 5, 6, 1, 2, 3, and the point 10 is way over here. 4 should be this one. Okay, now this one, a second ago, we're switching everything x and y. So a minute ago, we had the asymptote at y equals 2, and now we have an asymptote at x equals 2. And so our new asymptote, when we switch everything x and y, we now have this asymptote. And so this lovely function is the inverse. Okay, I did this other one here, same idea. The initial function was in blue. It was an exponential decay that then got reflected over the x-axis and then shifted and shifted. On that one, the pivot point was 1. Oh, my pencil turned off. My pivot point was at 1, 2 was the pivot point. And then I reflected everything and then took its inverse. Okay, let's look at these two word problems and then we'll call it a day. A house that cost $200,000 will appreciate in value by 3% each year. In Dallas, it's been more than 3%. Write a function that models the cost of your house over time. Okay, so we could call this the price of the house as a function of time, or the cost, whatever. And so our initial amount is this $200,000, and it's appreciating in value by 3% each year. Does that mean I'm just going to go 0.03 to the t? No, absolutely positively not. This would make my house lose value like crazy. So what it is it's appreciating. That means the value is going to increase, and this is my R value is equal to 0.03. So to find my B value, to find my growth factor, I have to do 1 plus my R value, which is 1 plus 0.03, and so this becomes a 1.03. Right here. That's the growth factor. Find the value of the house at the end of 10 years. Okay, so this is 200,000 times 1.03 to the 10. I need Desmos. Where are you? Come back, Desmos. Here we go. Go away. Go away. And I'm typing in 200,000. Did I have enough zeros? Yeah, look at that. It like grouped them for me. Times 1.03 raised to the 10. Okay, so now if this works, our house, pencil turned itself off. This is going to be approximately 268,783. We're talking money, so 0.28. So $268,000 and more. Cool. Okay, the next one, you have a bad cough and have to attend your little sister's choir concert. Oh, that sounds like great fun, but go to an orchestra concert. Those are better. Well, I play in an orchestra. You take 100 milligrams of cough medicine. Every hour, the amount of medicine in your body is cut in half. Right, a function. So we're going to do medicine as a function of time. Well, we have an initial amount of 100, and then we have half of it remaining after every hour. So T is going to be per hour. So notice T up here, this was per year, and this T right here is per hour. So, okay. Is it safe to take more medicine? It is safe to take more medicine when you have less than 4 milligrams. How long will it be before you can take more medicine? Well, let's see. We want to see, we have this 100 times 1/2 or 0.5, raised to the x. I want to see, where does that equal 4? I have to say it equals y. Oh, not x. Okay, so when I come and find the intersection on Desmos, it tells me that I'm going to be exactly at 4.64 hours. So, so maybe I'll take a screenshot of that and put this in my notes. How long will it be before I can take more? T is about 4.644 hours. All right, like, subscribe, comment, and the only way to learn math is to practice. So go practice.